Okay, it seems the first transfer went well. It's perfect. Now, it's time to welcome our second speaker, Jordi Cabot. He's a research professor at Interdisciplinary Institute, the research center of the Open University of Catalonia, where he's leading the SUM research lab. Previously, he has been at École de Nantes, Inria, University of Toronto, Politecnico di Milano, and the Technical University of Catalonia. He is a reputed expert in the area of systems and software engineering. His current research topics include pragmatic formal verification techniques, analysis of open source communities, open data exploitation, and the role AI can play in software development and vice versa. So today, Jordi is going to tell us his vision about the future trend on modeling. Welcome, Jordi. The floor is yours.
Thanks for the introduction. So let's just get into business. So to see the future, I think that we need to first understand where we are right now. So let me just warm up a little bit by talking about why we need modeling and what's the current situation of modeling right now. So as you can see, we have been modeling for a long, long time. In fact, modeling is just basically the history of software engineering. Yeah, so from zeros to ones to assembler to C to all the newer languages, programming languages that we have right now, always we have been going up. Well, we have always been raising the levels of abstraction. So modeling is just, let's say, the combination of this process from my point of view. And the importance of modeling is, recognized and understood in any other discipline. So this famous sentence from this architect is a clear definition of what also, in our opinion, are the benefits of modeling, right? So basically, modeling saves you time, allows you to simulate things, allows you to think through things before actually starting to code or actually starting to construct whatever you are building, right? So it seems that everybody understands the benefits of modeling. And to me, in fact, the question of whether we should or we should not model is the wrong question, because we are always modeling. Maybe these models are not made explicit. So maybe when facing a new problem, we are modeling in our head, and we don't take the time to actually take a modeling tool, open it, wait for Eclipse to launch, start a new diagram, start dragging, dropping elements into the canvas, and so on. Maybe we don't do that, but we still model in our head. So to me, the real question, and one of the key pillars of the talk of today, is whether it's worth or not to make these models explicit. We know that all models are wrong in the sense that all models are abstraction of reality, but we also agree that they are useful. So the difficult question that, of course, we are not going to answer because nobody has the perfect answer for that is when it's worth to actually take the time to make the model explicit. Again, we are always modeling, so the question is when it's worth to make these models actual artifacts in our development process. What models we should draw, when we should do them, how many, and this depends on so many factors, right? The size of the team, the size of the project, the domain we are modeling, and so on. So here we really have the key issue of the return of investment in modeling. So the cost of making this model explicit, the cost of actually learning a specific notation, the cost of buying a tool or using a free tool, but still you need to have a cost of actually using that tool in practice versus the benefits we are going to get out of this model. So it's kind of a very simple, right? If we can convince people that the time they put and the money they spend in actually modeling something, it's going to be beneficial in the end because they are going to get a positive return of investment, people will model. And this cost, and that's again one of the criticisms that I'm going to raise today, depends a lot of the tools. So it's not so much that modeling is difficult or easy, it's that the tools that we have today are making modeling probably more difficult than it should be. What can we model? What we have in front of you right now is actually a model. It's a model, in fact, that you all understand. It's a specific type of model that it's known typically as a map, but it's still a model that has a very clear semantics and a very clear notation. So if you look at the map, and there's a P, white P within a blue square, you all know that this is a parking sign, right? Because we know how to interpret this model, because since we were kids, we have been trained to understand maps. But this is a model of a city, and again, nobody would argue that this is not an actual useful model. In fact, everything is a model. Of course, software can be seen as models of software. Systems, cyber-physical systems that mix hardware and software components clearly can be modeled, can be simulated. They have digital twins as well for that. And in fact, any engineering process can be modeled. In fact, as we also discussed, probably software is the worst market for selling modeling tools, right? So typically modeling and modeling tools are better appreciated in other domains like systems and other engineering domains than actually in software. So let's see some types of models, just to again give you some, open your mind a bit, let's put it like that, and make you see that in fact everything is a model and we are modeling everywhere. So we created, for instance, in the team, a modeling tool for electronic components. This could be a snapshot, let's say, of the meta model that we created for that. But just look at the program for today's talks. We have modeling in automotive. We have modeling in robotics. We have modeling of types of models that help in accident reconstruction diagrams. Even music language is a model, right? So it's a domain-specific language for the domain of music that has a specific notation that I don't understand, but the people that actually does practice and plays music are able to very quickly grasp and interpret. So again, the modeling itself is not the problem. And in fact, any domain tends to modeling. As soon as any domain starts to mature, starts to really evolve, in the end, they always resort to modeling. So look at machine learning. Machine learning started with very low-level libraries that you had to program yourself. And now every major vendor of machine learning software or service or whatever ended up creating their own modeling platform for machine learning. What you see right now in this slide is the tool called 9. And what you see is basically is a kind of a workflow-like model that they invented. Of course, it resembles many other types of workflow modeling languages, but it shows a data science pipeline where you have forks, you have merges, you have splits, and so on. And indeed, there's an opportunity for us, the modeling experts, to go to all these domains and basically contribute our modeling best practices to these people, because typically these modeling tools are created by people that have not really modeling background. So there's a lot of improvements to be done. So if it's clear that modeling is so good, that modeling is so important, that modeling is so beneficial, I think that the next question that we need to try to answer is, so, okay, so why is not everybody modeling right now? Why they don't see the light? Stephen Mellor said already that, okay, in his opinion, modeling will be commonplace in 3 years' time. The only issue is that, in fact, he's been saying this since 1985. So clearly, there's something that we are doing wrong. We, as modelers, as people that love modeling, that believe in modeling, there's something we are doing wrong. And it's not that we don't have good modeling languages. So in this slide, you see there's dozens of modeling languages for all kinds of types of models. And some of them really going backwards a lot of years. So as a community, we have been able to produce plenty of different models and modeling languages. But so the problem is not so much on the semantics or on our ability to be able to invent notation that are somehow attractive. The problem is elsewhere. The first problem that I do believe we have is a marketing problem. And this is really a strong one. So modeling is not sexy, especially in some communities like programmers. So same as Agile was always seen as something exciting, amazing. Immediately everybody wanted to adopt Agile methods. We cannot say the same about modeling. In fact, the current trend is low code. So you see many tools that are selling themselves as low code tools or no code tools. And a low code tool is just a modeling tool with a code generator. So nothing that we don't have already seen before in model-driven engineering in general. It's just that they change the name, they remove the word model, and they add the word code. And that just this change seems to make a really strong difference in the community where we try to say enforce modeling. So again, modeling has a bad press. I think, in my opinion, this comes from the times where we were trying to sell UML as a silver bullet that would fix all the software engineering problems. So I think that there were a lot of salesmen that tried to solve UML to sell tools, and this is now kind of reverting back to us. I think that the only domain or the only application of modeling where everybody, I mean, even the programmers, believes that modeling indeed is good is reverse engineering. So every programmer will be happy to get some kind of a graphical representation of the code they have. And that we have experimented, we have seen with our own tools. The tools that we have that we create that are basically reverse engineering tools that go from OpenAPI or just Discord to UML are always the more successful we have. And then there are a lot of misconceptions about modeling, right? So people believe that modeling is not agile, that it's just for documentation, a posteriori documentation, and it's just nice pictures. So clearly we are not good at explaining and selling modeling. There's just still some hope. So the venture capital money still believes in modeling. Again, modeling using a different terminology. So OutSystems and Mendix, which are two very popular model-driven tools, got a huge amount of funding and were even acquired by other companies. Although they sell themselves as local tools. Lucidchart is an online drawing tool, so it's not really a modeling tool. But again, I think that they are part of our domain. It's just that they sell themselves as different things, and we have to learn from that and see what we can do. We also have a usability problem. Have you ever found a user that loves her modeling tool? Well, I don't. Why? Well, there are too many clicks to model anything. So you try to do a class diagram, you get bored of clicking things and here and there just to draw a few classes. There are too many options all the time available in the tool, typically, many of them that you are not going to use, but that distract you. And I think that we can also agree that the Eclipse EMF was a great environment, but maybe it's not that great anymore, and that we need to also evolve. I tried to teach modeling many times, including code generation as a way to make it more sexy, because I was thinking that you could better sell modeling if you were showing what you could do with the models. But I think that, again, modeling tools are not doing a good job to generate a good first impression. There's typically lack of documentation. They are complex to install and configure, and the generated code is not optimized. So on the usability, we can also improve a lot. And more now linking with what we're going to see next, I think that we also have an infrastructure problem. We are far away from the times where modeling was the work of one single person on a desktop or computer, right? So modeling is collaboration, modeling is security, confidentiality of models, and we don't really have good solution for these aspects. And modeling needs to be adapted to what the users want, need to be adapted to what the users are. So this means modeling needs to be better integrated with a contribution system like GitHub, need to be moved online, which is where many users are more comfortable with, and need to be made more flexible, right? So we are always trying to make sure that the models are correct, but sometimes we want to exactly have the opposite, have inconsistent models, because for the initial phases of the design, that might be the fastest solution and the more agile solution. And there's many other challenges I think we are facing as a community, but if you want, there's this paper that tried to collect all of them and present them in a sorted way. So what can we do then to have a better modeling, to have a more successful modeling, if we have seen that we have all these issues? So let's see some of the potential trends that could counter some of these problems that we have just seen. Of course, we just cover very briefly each of them, but in many of them, the team, my team has some tools or some work behind that. If interested, you just ask me. So first, we need new interfaces. We have already said that the desktop Eclipse environment is not the ideal scenario anymore. So what are these potential new interfaces? First of all, textual models are models. So not all models need to be graphical representations, right? We not always need graphical languages. Why textual models are better sometimes? Because, well, they are more friendly for developers, for instance. There's a lower barrier to entry. They are easier to integrate in current continuous integration pipelines. course, you can always put a textual model in GitHub and will be treated as a source code. You cannot say the same about the graphical files, right, which are much more tricky to integrate in a continuous integration pipeline. This doesn't mean that we should drop graphical notations. No, I mean, let's use the flexibility and the powerness of modeling. So we can have one DSL, one domain-specific language, one modeling language that has multiple notations. So we could have a textual notation to facilitate the easy creation of models, the easy writing down of these models, plus a graphical one to visualize and read these models, because graphical, for sure, it's better to understand a complex design. For instance, in our own team, we have a ChatKit, which is a chatbot tool. We have a textual notation created with xtext to define the kind of a state machine to process the events that the chatbot should react to. Of course, once you have a very complex chatbot, it's difficult to really follow all the states that are somehow implicit in this definition. So what we did is we write in text, we read in graphics. So then we use Sirius, of course, to basically create a graphical view of the same textual definition that you have seen before. And for us, this is quite good. So when I'm writing a complex bot, I typically move from time to time to the graphical visualization to make sure that the state machine that I'm seeing is more or less correct and I'm not really missing some transitions. Another big topic is moving to the cloud. So if you observe the programming IDEs, they are all moving to the cloud. So I think that we, the modeling people, should do the same. And right now it's easier than ever. So even in Eclipse, there are already some initiatives that could be used. In the front end, there's plenty of drawing libraries in JavaScript that could be used. And there are some interesting initiatives that you can follow. So there's EMF Cloud. In our team, we had the EMF REST, that basically was a REST API for manipulating EMF models. And there's also this language server protocol that basically, and there's also the kind of a proposal for a graphical language server protocol, because language server protocol, or LSP, was created for textual languages, that basically delegates to a server, a language server, all the complexity of managing a program definition, which makes easier to create a client for that language in multiple formats and in multiple domains. More things that we should really think about is modeling outside the modeling tool. So why we should model always within a modeling tool? I mean, some discussions take place in team messaging tools like Slack or like Microsoft Teams. So why not try to model it directly inside those tools, so that we facilitate the collaboration, right? Also using tools that people already know how to use, so they don't need to put the effort in learning new tools. So we could model it in Slack, for instance. Even more, we can model with our voice or with text, so we don't even need to learn the specific notation of the language or the commands that are required to actually create those details of the language. So we have been experimenting with a chatbot that lets you model. Again, it would be the same for a voice bot. So given the meta model of the language that you are trying to use in your project, you can generate a chatbot that will let you then create and query this model. So you will be able to create a new instance of the classes, of the meta classes, and then you will also be able to ask questions about the model you have so far and get the result instead of, for instance, using a language like OCL. That could be the process, but let me just move to the next one. This is all very nice, but it comes with its own set of challenges, right? So as soon as we start opening modeling to these new environments, then we need to start worrying about intellectual property, how we make sure that our models are not copied and used in different projects. Here we use robust hashing, which is a technique to easily and efficiently compare the similarities between models. We may also want to introduce some accountability. So again, if many people are modifying the same model, we may want to know who did what on the model and when, and probably even why. So here we can just use some kind of a storage mechanism that allows you to have this accountability linked to a blockchain as you want. We have a need for security. We need access control for models, because you may want to just restrict parts of the model to specific people. So you are outsourcing the development of part of the system. So those people that are doing that development need to see part of the model, but not the complete model. And of course, all this also links to scalability issues, where basically we cannot just do all this and then storing the model in a XML file, right? So we need using relational databases or even more NoSQL backends to really manage all this complexity. So this would be really the first trend of this kind of let's open modeling and let's use new interfaces. Let's not stick to the traditional ones. Then the second trend is AI-based modeling. I think that having a smarter tool would make us more productive. So it's easy to see with these examples. Mendix Assist suggests the new modeling actions that you are going to take depending on the state of your model, right? So they suggest the next steps, and then kind of it's faster for you to model, because if you agree with the next step, if that's exactly what you wanted to do, then Mendix do that for you. Similar, OutSystems has also a kind of a very nice help in the class diagram that basically paints in the background other classes that are typically connected to the one that you are modeling in that moment, and give you the percentage of times where, in this case, the class order was always appearing together with the class customer. So it's a way to it's not usability, what we have seen before. This is really auto-completion and kind of improving the productivity. This is very nice, just that you need a lot of models to train those systems. So if you don't have a lot of models, what we are now trying to do in my team is basically to do similar things, but using textual data. Because you may not have models, but for sure you have documents. So for every project, there's a lot of documents that have been created. So what we try to do is basically read those documents, and then based on the partial model that you're creating, to see what are the other suggestions that we can make so that you can complete your model. Of course, this AI can also be used not only at the modeling at the individual model level, but also at the manipulation level. So typically in any project, you have plenty of models that need to be synchronized, that need to be transformed, and so on. And this is typically very complex to implement, right? So it requires learning new languages for transformations. You need to write those transformations. You may make mistakes and so on. So how can AI help here? I will not get into the details, but the idea is that if you have, again, enough input-output models to train a neural network, you could then use this trained neural network to transform the models automatically in the future. So you have plenty of VPN models and petri-net models. You can train a neural network and then use this network to basically give a new VPN model. Forget about executing the information, just let the neural network do the work. In our work, we have used specific type of neural network, which is called STM, long short-term memory networks. This is architecture. Again, if you're interested, please go to the paper. It's kind of a complex architecture, this encoder-decoder. We have used this not only for transforming models, but also for generating code in a way that the code that is generated is similar to what the user is used to see, which again is make it more familiar. So it's an area where there's plenty of research, there's plenty of exciting things to do. I will also say that so far the results are not so good because we are very naive. We, meaning our team, since we're not expert on machine learning, and we realized quickly that neural networks are much more stupid than what we thought. So the training has to be really exhaustive to get the good results. But for sure, I think that the combination of AI and modeling has a long way to go and could bring a lot of interesting surprises. And the last trend is personal modeling. So I think that we should avoid trying to create a one-size-fits-all solution. Every person model is different. Every domain requires different tools. So we need to react to the reality. I think that models are not, as we used to see them, as a static, fixed, and complete artifact that we do at the beginning of the project, and then basically we carry on with them. They are rather a partial view of the reality, dynamic because it changes over time, is personal because every individual needs a different perspective on these models, and is temporal view of the domain. So the challenge is how we adapt the tools and the languages to this reality. Couple of things that we could do. Again, we need to adapt tools. Maybe we could have a morphing modeling tool. So again, mixing with the previous concept, a morphing modeling tool is a tool that learns from the way you're actually using the tool and adapts to that. For instance, if the tool realizes that you're never using a certain feature in the menu, let's hide this unless you are explicitly requires them. But also customization of the notations. Why we need one universal notation? We need universal language or universal language specific domains so that we can share and understand each other. But this doesn't mean that the rendering of those notations needs to also be common. Maybe here there's some flexibility and capability for us to really have advanced to this more personal notation that would make you more productive. One of the tools that we have developed in the team, together with my previous team in Nantes, is EMF views, which basically allows a designer to define viewpoints. So you, on the one hand, you have the models, but then you have viewpoints that are basically a specific view of the models that are needed for a specific user profile. And then based on these viewpoints that are defined, you create the models that external people will see. These people will see these models, may even have the option to modify slightly these models, but we not have access to the full meta model that are behind. And basically, we are creating a productive view of this complex system for the needs of specific user. Going to these lines, we should also work on this idea of have extensive and composable DSLs. I mean, of course, there's already plenty of work on this. So I think it's important to keep going in this direction. We don't really want to have a universal language. Let's not reinvent UML. That didn't go so well. So we want is to have for each domain a core DSL that is interesting and it's useful and adapted to the domain, plus a certain libraries that can extend this DSL depending on the needs of a specific project. So if we need uncertainty modeling, we can add that library. If we need temporal or spatial modeling, we can go and adapt that library to this core. But let's not create a gigantic DSL that in the end, again, they just end up resembling UML and having the same kind of issues. So somehow this idea of profiles that was not so bad, even for UML, I think at least personally I like it. I like it quite a lot. I think could also be introduced here. So as we have seen, we need personal, flexible, agile modeling tools that at the same time are modeling tools and not just drawing tools, which again, it's a different problem, right? We don't want to just draw diagram without semantic. We just want to draw models, but these models need to be something that is really agile and adapted to specific domains that use new environments. So again, cloud-based, Slack-based, using bots. So I think that at least we're not there yet, but I think we're getting there. And I think that Sirius and some of the novelties that I'm hoping they will present today will help us to go into this direction of improving the way we create modeling tools so that we can provide better solutions for the modelers out there. Thank you for listening.
Okay, thank you, Jordi. Okay, actually, we are just in time, so we don't have so much for questions. Okay, I just want to remind that the Menti link provided by Melanie in the first talk concerned just OCP and Melanie's content. So if you have any questions for other speakers, including this one, please use the Ask a Question feature here. I picked a few questions from the forum here. One topic concerns the code generation and is mainly how can we generate correct code or sensible code using model, and the second one is more maybe an interesting idea to use AI to generate nice looking diagrams. So as we don't have so much time, I will leave you in this room discussing with okay. Jordi, and I will prepare the next talk. Thanks again, Jordi.
Thank you.